Hey everyone, welcome back to my channel where we explore the fascinating world of physics and beyond. Today we're diving into a question that has puzzled scientists and thinkers for ages. Why can't we move backward in time the way we can in space? What makes time seem so different from space? But here's the twist. What if I told you that time isn't different from space at all? It's not about time being special, it's about something much deeper. It is about quantum coherence. It is possible to travel back in time to the past. In fact, we can say time travel to the past is being done all the time. But backtracking through temporal dimension to the past state will backtrack all the experiences, and so the memories of the system will be backtracked to the past state. Therefore, even if we travel to past states, we or any system will not have the experience or memory to experience time travel to the past. Let's start with the basics. In Einstein's theory of relativity, time and space are treated as part of the same continuum, spacetime. This means that, theoretically, there shouldn't be anything inherently different between moving through space and moving through time. But our everyday experience tells us otherwise. We can move freely in space. We can move forward. We can move backward. We can move up. We can move down. We can move left and right. But what about time? We're stuck moving in one direction from the past to the future. So what's going on here? The answer might lie in quantum mechanics, particularly in the concept of quantum coherence. Coherence refers to the way quantum states, represented by a wave function, maintain their phase relationships over time. Now, these wave functions have a property known as wavelength, and this is where things get interesting. Along spatial dimensions, the wave function's wavelength is incredibly small, so small that it's not easily disturbed by the wavelengths of energy or matter. It should be noted that for interaction, the wavelengths of entities must be comparable. This allows the points in space to maintain their coherence, meaning we can move around in space without disrupting this coherence. Spatial movement is reversible and doesn't introduce any asymmetry. You can walk to the store and walk back home, no problem. But in the temporal dimension, things are different. The wave function's wavelength along time is much longer, and crucially, it's comparable to the wavelengths associated with energy and matter. This comparability means that the coherence between events in time is more fragile. As you move forward in time, interactions with energy and matter disrupt this coherence, making time appear to move in only one direction, that is forward. This disruption is what we perceive as the arrow of time. So it's not that time is special or fundamentally different from space. Instead, it's all about the robustness of coherence. This isn't about time being unique, it's about how quantum mechanics plays out differently in time and space due to these wavelength scales. This idea has profound implications. It suggests that the difference between our experience of time and space isn't due to the dimensions themselves, but rather how quantum coherence operates within them. You see, spacetime is a state space whose points are spacetime states called events. These events are specified by space and time coordinates. The transition from one state to another state in this space happens at a maximum cosmic speed called the speed of light. The transition of state is called motion through the state space. The motion is distributed over the spatial and the temporal dimensions. The maximum speed at which the motion occurs in spacetime state space, and in particular in space and in time, may be related to the superposition wavelength along space and along time respectively. The minimum wavelength along time cannot be smaller than that along space, so the maximum speed along space when it comes to entities with non-zero rest mass, or entities that are classical, is always less than their maximum speed of motion along time. The spread of an entity's wave function for a classical entity cannot be more confined in time than its spread along space. What this means is that we as a classical entity can be in one place at multiple times, it can be at multiple places at multiple times, but the correspondence is at most one-to-one. For each space coordinate there is at least one temporal coordinate, but for each time coordinate there can be no more than one spatial coordinate. We as a classical entity cannot be at multiple places at the same time. These limitations, along with the speed limitations, are related to the wavelength scaling of superposition and coherence of spacetime points, or states, connected along temporal and spatial dimensions. By the way, we can make a small observation about coherence and observation itself. Coherence is relative. If two waves are in or come in coherence, they can be regarded as one wave, which maybe is not in coherence with some other wave. And if two waves that are in coherence, one might decohere from the other and become coherent with some other wave. Therefore, decoherence with one wave maybe is coming to coherence with another. If the conditions were different, if the wavelengths in space were longer or those in time shorter, then we might experience time and space in ways that are completely unimaginable right now. So next time you think about why you can't just jump back to yesterday like you can walk back to your house, remember it may not be because time is some special dimension. It might be because at a quantum level, the coherence that holds our universe together is playing by different rules in space and time. Thanks for joining me on this mind-bending journey into the fabric of spacetime. If you enjoyed this video and want to explore more complex ideas in physics, be sure to like, subscribe, and hit that notification bell so you don't miss any of our future videos. And as always, drop your thoughts or questions in the comments below. I'd love to hear what you think. Thank you for supporting me again. You have been very generous. You guys are awesome. See you in next videos. Bye. It's been a great pleasure.